Finally, for problem number 6, we see we have an absolute value function that we're supposed to graph. And in graphing an absolute value function, we're looking for a v. We're looking for where is the vertex of the v. And so when all else fails, guys, you can just plot a bunch of points. So let's say we'll pick a value for x, let's say -3. That would make that whole part 0. And then 0 minus 4 is -4. So we know that 1, 2, 3, 1, 2, 3, 4 is a point on the graph. If we plotted, it makes it a little bit more difficult because of this 2/5 out here. So if we pick a strategic value, like let's say 2. 2 plus 3 is 5. The absolute value of 5 is 5. 5 times 2/5 is 2. 2 minus 4 is -2. So if we pick x to be 2, we get y is -2. What other, let's think, what other good x value? How about -8? If we plug in -8, and I'm looking for multiples of 5 that 5 could divide evenly into. -8 plus 3 is -5. The absolute value of -5 is 5. 2/5 times 5 is 2. 2 minus 4 again is -2. So I can go over to -8 and go down to -2, and I have another point. From there, I could probably just draw the v. It looks like it comes right down to that point right there. But so if all else fails, I could just make a v right there and hope for the best and hope that that's the vertex. I would go, okay, vertex, -3, -4. It looks like -3, -4. I can get out of that. So yeah, most likely that's the vertex. And I would just draw the graph like that. If I didn't have a ruler, I would just draw it and try to make it look as much like a V as I can. Okay? So that's one way you could do it. The other way, which would use the transformations that you've learned, is number one, you've got your h value that's subtracted from the x. H since we have an x plus 3, it would mean that x minus -3. It means that -3 is being subtracted from the x. Therefore, h has a value of -3. The k value is just that number on the outside. If it's -4, then the k is -4. So therefore, we would know that the vertex is at -3, -4, which is exactly what we found before. The domain of all absolute value functions is always all real numbers, all x values. And the range, on the other hand, is the lowest y to the highest y. Low to high. Low y to the high y. And the lowest y would be -4. That's as low as it'll get, including -4. Make sure you put a bracket there. And then the highest y, well, it keeps going on forever, so therefore infinity would be the end of that interval. So the all real numbers y greater than or equal to -4. You could write it like this: y is greater than or equal to -4. You could do that. And then increasing. So this is where we had the red light, green light. So remember, if you do remember, we've got red and green. Red for the interval in which the y values are getting smaller, so all the way down to that point right there. And then green for the interval where the y values are getting bigger. Green. That's just the intervals. And increasing then on the interval from -3 all the way to infinity. And then decreasing from -infinity to -3. There we have the intervals. There's no horizontal asymptotes, no vertical asymptotes. The x-intercepts, let's go ahead and see if we can figure out the equation for that. So the x-intercepts, we're going to let y equals 0. We get 2/5 times the absolute value of x plus 3 minus 4. Well, let's go ahead and add 4 to both sides. We're going to solve this. It's a good reminder of how to do this. And then when we want to get the absolute value bars by themselves. To do that, we could divide by 2/5, but dividing by 2/5 is the same thing as multiplying by 5/2. When you multiply any fraction by its reciprocal, you get 1. So 5/2 times 2/5 is 1, and the reason why we do that is so that we get the absolute value bars by themselves. 5/2 times 4, 2 goes into 4 2 times. 5/2 times 4 is 10. So we get 10 on the left side equals the absolute value of x plus 3. Now this is harder to remember, But when the absolute value of x plus 3 equals 10, it means that x plus 3 is 10 units to the right of 0, or what also would solve this equation here is setting x plus 3 equal to 10 units to the left of 0. So we have two equations that we can create that make this equation true. Either inside of there is negative 10 or inside of there is positive 10. If we say inside of there is negative 10 and we subtract 3 from both sides, then x could actually be negative 13. And if we subtract 3 from both sides over here, we can see that x can be 7 as well. So what we see, if we look at the graph, we realize, oh, we have two x-intercepts. Clearly, negative 13 and 7 is what we found down here. And that would be reasonable if I drew the graph perfectly, up 2 and over 5, up 2 and over 5. Then I would get 7 right there as an x-intercept, up 2 and over 5, up 2 and over 5. 5 away from negative 8 is negative 13, somewhere over here. So that's how we find our x-intercepts. Let y equal 0 and solve the resulting equation. And we get negative 13, 0, and 7, 0. Now the y-intercept, on the other hand, that's a little bit trickier. So I'll do that. I'll do the rest of this in the next video.